Hello everybody, welcome to another video in which I try to explain physics as simply as possible but not simpler. And today we will discuss the topic of relative motion, relative speed. So let us talk about uh, everyday life examples. So first example, here I tried to draw the railway and this is the train, okay, and this is a tree next to the railway and this is a guy standing next to the tree and this is a guy walking inside the train. So and this here is the guy sitting on a chair inside the train. So let's say the train is moving with speed 100 kilometers per hour and this guy is walking inside the train with speed 5 kilometers per hour. So according to let's call them A, this guy is B, this is C. So according to guy A, passenger C, first of all, the train is going 100 kilometers per hour. And according to A, C is moving with speed 105 because the train is moving 100 and he is going with speed 5, okay? And if he was going in the opposite direction inside the train, at this time he will say that he is moving with speed 95 kilometers per hour towards him, okay? But what guy B would say? He would say that the train with respect to him is not moving, so the speed of train is 0, that this guy is moving with speed 5 towards him or 5 opposite to him, and he will also say that the tree and the guy A are moving with speed 100 towards him, okay? So from this simple example you see that the motion and speed are relative, which I mean that in one reference frame something can move, but in the other it can be at rest, it can have speed 0, like this train is moving in reference frame related to A and is not moving in reference frame of guy B, okay? And also speed is different in different reference frames. Okay, let's discuss another example. So suppose this is a car and this is moving with speed 60 kilometers per hour and in front of it it's another car going faster 80 kilometers per hour in the same direction, so maybe it just overtook this car. So let's say this is car A, this is car B. So these are speeds in the reference frame related to the surroundings, to the road or the tree which is next to the road. But what is the speed of car B with respect to car A? So in the frame of in the reference frame of A. So I think you intuitively see that this speed would be 20, so 80 minus 60, okay? So B is moving with speed with speed 20 kilometers per hour with respect to car A, okay? And how it will be if okay, car A goes as before, but now imagine car B is moving towards it with speed 80 kilometers per hour. Okay, so what's the speed of B in reference frame of A? So what's the speed of B with respect to A? So yeah, it would be 80 plus 60, so it would be 140 kilometers per hour. Okay, so this shows you that the overtaking is so difficult, so dangerous also, because I mean, if you have the road like this, that there is one lane in each direction, so if this is a bus or something and you want to overtake it and the car is going from the opposite direction on the same lane, then it's even if you are going with speed 80 and it is going with speed 60, then it is approaching to you, closing to you with speed 140 with respect to you, so very very quickly. Okay, so this difference between this case and this case, so in both you have 60 and 80. What's changed? Only the direction changed. So you remember, speed or actually velocity is a vector. So it's an arrow, so the direction matters. So here you see this intuitively, but there can be more, a little bit more complex situations. For example, a little, let's say, airplane made of a piece of paper, if it's flying with some speed in this direction initially, but there is a wind blowing at some like in perpendicular direction, or maybe at some angle, so you need to remember that this is one vector, this is another vector, and to have the net result you need to add them as a vectors. I discussed how to add vectors, and I will also discuss these things, relative motion in more detail in when solving specific problems in next video, so I invite you to check them. But first let's make some final remark, that these simple formulas like to add or subtract two velocities, they assume that these velocities are much smaller than the speed of light. If this is not the so this assumption is of course satisfied in almost all everyday life situations. You don't see cars going with speed of light, but you can have you can have elementary particles like electrons or protons going with almost speed of light, or just light is going with speed of light. So in this case the equations are much more complicated. There you need to use the special relativity, which is beyond the scope of this video at this level. I hope we will get to it later on. So that's all for today, and I invite you to the videos where I will solve the problems related to relative motion, and hopefully you will understand it better with them. Thanks.